Hey guys, what's up? I'm Charan from Just 3D Things. In the previous videos, we have seen how math works in Blender and other few math functions. Using that knowledge, let's build this advanced checker texture from scratch. You can download the file for free from a Gumroad. Before we make the pattern, let's first understand it. As you can see here, we have both blacks and white squares alternatively. So if you think about it, we need a way to make an array of values of 0 and 1 where black is equals to 0 and white is equals to 1. So the math function that goes from 0 to 1 and 1 to 0 and so on is sine and cos if you think about it. Let's get started by understanding the math behind it and what the pattern is and how I came up with the idea. Do you guys know that we can plot 3D graphs in Blender by giving an equation? Yes, it is possible by this amazing add-on called Extra Objects, which comes within Blender, and you can activate it by going to Preferences, Add-on, and by searching for Extra Objects and enabling it. Now let's add the 3D graph. For that, we need ZMath surface. Now Shift A, Mesh, Math function, ZMath surface. Now by default we get this equation and the surface. Now let's plot sine graph. You can change the equation here. You can change the size and resolution here by increasing these values. And let's also visualize the sine y graph. It's the same but rotated about 90 degrees along the z-axis. Now what I'm going to do is I'll just multiply sine x and sine y. I'll tell you in a moment why I'm doing this, but let's do that first and let's see how the graph looks. Before multiplying both of them, let me place sine x and sine y on top of each other. And let's see how it looks. Here we can already see a square pattern going on. This is gonna be our base of our checker texture. Now let's see how it looks when we multiply these two functions. As we can see here, it looks like an average of both sine x and sine y. But what exactly is happening here is the sine x graph is sweeping along the sine y graph, and similarly the sine y graph is sweeping along the sine x graph. When we look it in the front view, all these points are equal to 1 and all these points are equal to 0 and the lower points are negative. To understand this better, I will link a video in the description. You can check that out. So we finally made alternate zeros and ones on both x and y direction. Now all we need to do is to recreate the equation in Node Editor. So let's get started. Now let's create sin x into sin y in Blender. For that, first I'll add a texture coordinate node and then change it to object coordinate system. Now I'll add a separate xyz node and a math node. A math node is for computing the sine function. Now connect x to the sine. Now we computed sin x. Duplicate the math node and connect y to the socket. Now we have sin y. Now to multiply these both, we can duplicate the sine node and change the operation to multiply and then connect these two outputs to the inputs of multiply node. We can already see a 2 by 2 checker pattern here. Here we can see this gradient again. To actually remove this, we'll use a greater than node. So duplicate the multiply node and place it over there and change this to greater than. What this function does is it checks all the points where the value is greater than the given threshold and rounds those to 1 and elsewhere to 0. And yeah, that's our 2 by 2 checker pattern. Now let's see how to control the scale. Let's go to Desmos and let me show how we can do that. Let's consider a simple equation, say y is equals to sin x. Now let's see what happens if we multiply some value to x. We can see that it is scaling along the x-axis. The same happens when you multiply something to y. Now let's get back to Blender and let's try to include it in our node setup. So now we have to compute sine of a times x into sine of b times y. So for that, let's add a multiply node and place it between sine x and x. We can use a second socket to control the scale along the x direction. Now duplicate the multiply node and place it between sine and y.
We can use the second socket to control the scale along Y direction. Now, to control the overall scale, let's add a vector math node and change the operation to scale. Let's place it after the object coordinate system. This node scales the whole coordinate system by the factor you give. Now we have the whole overall scale, X scale and the Y scale. Now let's see how to change colors. For that, I'll add a mix RGB node and use the output of greater than node as the factor. Now we can change the colors by changing the color 1 and color 2. And we can use the greater than node as a factor as well. Also, we can change the rounding of the squares by tweaking the threshold. Now let's make a node group by selecting everything and pressing Ctrl G. Let's drag the colors to the group input and then let's drag scale into the group input. These two multiply nodes are X scale and Y scale. Let's drag it into the group input. For the roundness, let's drag threshold into the group input. And finally plug the color output into the group output. Now let's rearrange and rename the inputs and outputs of the node group. And finally, I want a way to control the thickness of blacks and whites. Let's see how we can do that in Desmos. In this sine wave, the area occupied by the positive part of the curve is white and the area occupied by the negative part is black. That's because anything that is below 0 is black in Blender. Now, when we offset the curve along the y-axis by adding C to it, we can see that the area occupied by the positive part increases and the area occupied by the negative part decreases. This is nothing but controlling the thickness of whites and blacks. Now let's add this to our node group. Now let's duplicate the sine node and change to add, and duplicate the add node and place it after sine y. Because I want even thickness, I will connect the same value to these two nodes and add it to the group input. Now we are done. That's it guys, we have built ourselves an advanced checker texture. These are few patterns that I have got using this node group by tweaking the values. You can download this file for free from my Gumroad account. If you like this video, give it a like and subscribe to my channel for more upcoming math tutorials. And thanks for watching. Have a good day.